So we have a parabola again in a straight line. They intersect at P and S as shown. So here is P and that is S. And the points R and T are given there on the parabola. And Q, 0 and -2, is a point of G, which is clearly a y-intercept of G in this case. Okay, V is the turning point of the parabola. The straight line makes an angle of 45 degrees with the x-axis. That is definitely good reason. So let's see. Question 6.1. Show that the equation of g of x is minus x plus what? Plus t. You remember Benjamin, right? So Benjamin confirms that the slope here must be negative because it's decreasing. Benjamin, see, but here's Benjamin.
Oh, I know. I never knew it was Benjamin.
This is Benjamin.
I found that out again.
The slope man.
I know him as a yeah.
So that's it. So we know from the slope method that definitely we're going to get a negative gradient from the straight line. So we're going to have the equation as x plus what? 2 because of point Q. Now all we need to find is the gradient. Maybe I should write this as mx plus 2. Yes. So that we are aware of the fact that we've got to calculate the gradient. Now, nothing much is given except for one little bit of critical information, the 45 degrees. So now, here's what we need to remember from analytical geometry. The inclination of a line, of a straight line. Although they have given 45, we have to take note that the actual inclination is the obtuse angle. The obtuse angle, of which if we use angles on a straight line, it is 135. Now we know that m is tan what? Theta. This is one of the equations or formulas that are given in the information sheet. And what are you going to get there? -1. So it comes out clear now that the equation is indeed minus x plus 2. Is that fine?
Yes, sir.
Cool. That is 6.1. We move on to 6.2. The coordinates of S, I would not even bother myself much here because S is the x-intercept of G. You see that? So for 6.2, I must just make y0 in the equation of G. So I have minus x plus 2 like that, and it becomes clear that x equal to 2. So the coordinates of S, if we are to write them in coordinate form, 2 and 0. Cool. 4 marks in the back so far. And then the key question, show that the equation of f of x is 8x squared minus 12x minus 8. Now we are blessed or fortunate enough here to have the 2 coordinates and a point. Now if you have 2 coordinates and a point, it is actually easy to find the equation. How do you find the equation? Exactly. Here's the form that I want you guys to know from this moment onwards. We have this form that says a x minus x1, x minus x2. If it was a cubic function with 3 intercepts, we would have put x minus x3. You'll see that later when we do calculus. Okay. Why are you so traumatized now, Siba? What's the problem? Okay, the key thing is to find a, right? So I'm going to substitute 1 and 12. Remember, 1 is the x value, and 12 is the what? Actually, negative 12. Negative 12. Negative 12 is the y value. Now, the formula says x minus x1. So if I subtract the first intercept, it moves from minus half. It changes from minus half to plus half.
You said plus 2. I said minus.
And then the second one, it changes from a plus 2 to a minus 2. Because that's what the formula says.
I said minus.
Okay. Yeah, of course, minus a half. So that's how you get plus.
Oh, yeah.
Okay.
What I put a plus there for minus.
Okay, that's what it should be. But let's see what really happened here. Okay, this is 1.5. That is minus 1. Do you see that? 1 minus 2 is a minus 1. And this one is 1.5, which is 3 over 2. So I have 3 over 2, negative 3 over 2a. That's what I
So the
said.
calculator is wrong.
No, the calculator is not wrong. Yeah, you did not press it. Okay, so now we're going to tip and times. So in other words, I need to get rid of the negative 3 over 2. I need to get rid of this thing. And how do you do that? You multiply both sides by negative 2 over 3. Basically what we call the reciprocal. Do we see this? So 3 goes once here, goes 4 times, then negative multiplies out the negative. 2 times 4 is 8. So a is indeed 8. Now we have everything. Let us write the equation in the form that they want. So they have specifically stated it must be 8x squared, blah, 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 blah. So let's see. Here's 1, yes. A is 8, x plus a half, x minus 2. You see, I'm just putting back my intercepts. Then, so this is therefore, you are continuing. X squared, x and x. Then you have minus 2x, and then you have plus half x, which is minus 3 over 2x. If you add that up together, and that's a minus 1. Okay. Then if you simplify this, what is your question, Siva? Then this is 8. What? This thing on the left side, the thing in green. I'll show you. So that's 8x squared minus, now you see where the 12 comes from. 3 over 2 times 8 minus 8. Okay. Are we here, gentlemen? Okay.
I understand the concept.
Yeah, what's the problem?
The problem is just putting it in the calculator. That one is
This part here.
this part.
This part here. Oh, you don't have to put a. You just have to say 1 plus a half in bracket times 1 minus 2 in bracket.
You see, this is what I did. I just put it in.
Did you get that? Is that what you really did?
Or I should just say 1 plus this.
That's what I'm saying. Just okay.
But that's say 1.
Fine. Let me bring my calculator as well. Maybe this will be better if we do it together here. So what is the story there? Okay, let's go. You said 1 minus a half, but the half is a negative, isn't it? So you must do this now and close the bracket like that, and then you have 1 minus a 2 like that. So you should have gotten the correct.
Oh, what did I do? I just include the first bracket.
Probably yes. So that's how you type it in the calculator. So that's how you get that negative 3 over 2. Okay. Are we fine?
I was in a good direction.
Yeah, you're in the right path. Okay, that was 6.3. Now, the coordinates of the turning point, this is the fun part. I love this because I want to show you the non-conventional way. If I use for x equals to minus b over 2a, but I'm going to show you, I'm going to have fun here. This is 2 and 0. So what I'm going to do is, I'm going to add the negative half and the 2 and divide that by 2. I'm going to find the turning point of B.
Okay,
By finding the midpoint, the midpoint of the x-intercepts.
I'm just going to use that thing and do
That's fine. Yes, that's fine. You can use that. But I'm just going to have 1 as I said.
Okay.
So the x coordinate at V is just minus half plus 2 all over 2, which is the same as minus b over 2a. Same thing, exactly same thing. So that's 1 and half, that's 3 over 2 divided by 2. Looks like it's a 30. No, it can't be a 30. It's a half. It's a half. It's a half. Yeah, so look at this. This is going to be 1 and half. It's a half. It's a quarter.
Really check now.
It's a quarter.
It's 5 over 4.
5 over 4.
So 1. I do this.
Oh, I see. I see why you use my bad. No, I think the reason my mind is so slow is because it's after 4. That's the numerator is 3 over 2 here. Can we agree on that? Minus half plus 2 is 3 over 2. That one I will find.
Ooh, is that x? X is 3 over 2.
Right? So now I'm dividing this by 2 and I'll have 2 times. So 3 over 4. So that's the correct answer.
Oh, yeah.
So now, because they want the coordinates, you have to substitute this 3 over 4 way in the order exactly the original. So f of 3 over 4, what do you get for that?
You get negative 25 over 2.
Okay, negative 25 over 2 seems to make sense because we are on the negative y-axis. Okay, perfect. Then, lastly, I think I would expect Luca van Ross to answer this because it was yesterday's discussion. I would expect him to answer
This is how to determine the values of k if fx
has distinct unequal roots. Yes.
to unequal roots.
Yeah, they don't have to be equal. The two there has to be it has to cross the line k twice, but they don't have to be equal. So that's the main argument.
No, I never knew that.
Twice.
You know what I did? That was the nature of the roots thing.
Well, that's a good idea, but
Yeah?
it's a good idea, yeah. Yes, talk to them.
So
It's just that here they're saying this graph, so it's 1 mark. And nature of roots is a long process.
Yes, because
Answer.
so it can't be more than it's unequal.
Yeah.
So that means they have both have to be negative.
Don't worry about being negative or positive. The bottom line is they just have this line, the blue line has to cross the parabola twice. That's just the whole story.
And then with the x's can have to be unequal.
Yes, they are unequal by default.
So anything below v should not be.
It's not a root, that's non-real. That's the non-real case, but we don't want the non-real case with that. Yeah, we just want the unequal.
Anything above.
But anything above B, yes, above B, that's it. So that's it. And we don't want it exactly at V because when it is at V, there's just one.
See, that's what I was going to say, but
Yeah.
because it's only one solution.
Exactly. At V is just one solution. So we will have to say K must be bigger than what? The Y value at V, which is this negative 25 over 2. So that's what we're going to say. K, you said anything above, excluding. So this is negative 25 over 4. So at negative 25 over 4, we have exactly one solution. But we want 2 distinct and equal roots. So it must be above. So we will have to say K must be above negative 25 over 4. That's it. Okay, let's answer the classical question now. The gradient of f and the gradient of what? Of g. Strictly less than what? Okay.
Oh, wait, I think I understand.
Yeah. Now remember, don't panic. The gradient of G is what?
-1.
Minus 1. Exactly. Yes, we calculated it, remember? The gradient of G is what? Is minus 1. So you don't have to stress about this little thing here. That's why they're saying use the graph. So the gradient of G is never going to change. It will always be minus 1 throughout. Now, for this thing to be negative, that means we just want the part where F will be positive. Because remember, it's a times. So
That's what I was saying.
times to get a negative is if you multiply a positive.
And do you know what's the problem?
What?
It's adding.
The derivatives. The derivatives are referring to the gradient. Again, here, they are basically saying the gradient of F times the gradient of G.
Oh, I never knew. I thought it was like the way it's like the reflection is gradient.
Yes, parabola has a gradient as well. It is the first derivative.
Which one is this?
Well, if you find the first derivative of the parabola, it's going to be 16x minus 12.
Isn't
But
that
you don't-
calculus?
That's calculus, yes. But you don't need to do that. Let me show you how Benjamin comes into play here. This guy is a legend. You must respect him. Watch. Watch. Look at how Benjamin comes in. Benjamin says, if you are to find the gradient of a function like the parabola, just do this. First of all, right at the turning point, the gradient is 0. You know that. But for this region, the gradient is going to be what? Negative. And for this region, the gradient is going to be what? Positive. That's what Benjamin says. Negative, positive, 0, 0. But what we want? We only want the gradient to be what? Positive. So according to Benjamin, we have established that for the straight line, the gradient is going to be negative always. Doesn't matter. So according to Benjamin, the gradient of the parabola is positive from where? From the turning point onwards.
To the positive.
Exactly. To the right, actually. That's what it says. And we know for the straight line, it is forever negative. So therefore, our solution will be what? From this x value here at the turning point, which we have calculated to be 3 or 4 onwards. So we will say as long as x is bigger than 3 over 4, we are in this.
So okay, you know what I usually do? I look where the graph is positive and where the graph is negative.
That is if they said f of x, but now they say f prime. So when they say f prime, they are referring to the gradient. Yes.
So you just look at the gradient.
Yeah, just use Benjamin. Benjamin is responsible for telling you the gradient of any curve. That's what he's done. That's what he's doing. Yes. If you are not sure of the gradient of it, well, if you are not sure of the sign of the gradient, just use Benjamin and that curve. It will be helpful to tell you whether it is positive or negative. Are we together? All right, cool. And this is transformation, but I don't think I'm going to waste my time on that one. Okay? Let's stop this one here, and I'll give you guys the next last question. All right?